Yeah, I was talking about the third point. Third point says that complete conjugation in the molecule. So I was telling you that I believe that you know it pretty good, pretty well. What is a complete conjugation? Single, double, single, double, single. Throughout, throughout the molecule, it should be continuous. Okay, there should not be any breaks in it. So these are the three very famous conditions for aromaticity. So what do we mean by that? If any of the condition is not being met, the compound will not be aromatic. Okay, just write the third condition as well, and then we will be seeing some more insights into aromaticity, and then we'll also solve some questions and also see some examples before it. Just write down the third condition: complete continuous conjugation in the molecule. That's it.
Complete continuous
Conjugation. Let me know when you have written complete continuous conjugation.
sudden.
All right, let's move ahead. Okay, now let's see some more things. Yeah. See, now what do we mean? Not mean, but what is the significance of aromatic compounds? Aromatic compounds. In aromatic compounds, pi electrons are delocalized over the entire ring, and it is stabilized by pi electron delocalization. Very understandable things. In aromatic compound, we know there are pi electrons. We know they are delocalized, and they are stabilized, and the entire ring is stabilized by the pi electron delocalization. Okay, so there is a sort of stability associated with the delocalization. That's why aromatic compounds are highly stable. Okay, so let me also tell you that these aromatic compounds, their reactivity is less. Like benzene. Benzene is a very, very famous aromatic compound. And let me also tell you, benzene is quite stable. Benzene is organic solvent, organic industrial solvent for many things. Okay, many paints, dyes, other synthetic chemicals contain benzene in it. Uh, Benzene is also, and benzene derivatives, benzene and its derivatives are used highly in the cars, automotive sector, automobiles. Okay, because it's very, very stable. Okay, and benzene is also toxic, not good for health. Okay, okay, let's see some more. Aromatic, the second one I am reading. This is the, let me tell you, this is the second one. Aromatic compounds have very high resonance energy. Definitely. The resonance energy is very, very high. What do I mean by resonance energy is very, very high? The resonance energy is the difference between the canonical structure and the hybrid structure. Okay. You all know what a hybrid structure is. Let me tell you canonical structures of benzene and hybrid structure of benzene. It will give you idea. Like I can say, these both are canonical structures of benzene, and its resultant hybrid is this. This is the hybrid. This is the hybrid structure, and these are the canonical structures. So the energy difference between these structures is huge. These two and this, the energy difference between this is huge. Okay. Can anybody tell me whose energy would be more, canonical or hybrid? Yes? Anyone? Can anybody tell me, does these canonical structures are having higher energy, or this hybrid structure is having the higher energy? Come on, take a wild guess.
Both are same only.
That is not possible. I have written energy difference is huge. Yes.
So canonical.
It is, acha, canonical structure energy is more, you are saying?
Yes, sir.
Yes, that is true. That is true. Canonical structure energy is more. Energy is more here, which is bad, which is a bad thing. Hybrid structure energy is very less. And if energy is less, that structure is known as stable. Okay. When you are having less energy, you are stable. So let me explain you what am I trying to say. For example, you are angry. You are in an angry mood. You are sitting and you are very angry. Your cheeks are red. You are shouting. So whenever you are showing anger and whenever you are angry, when you are having more energy, you are unstable. When are you stable? You are stable. You imagine sitting at beach, relaxing, hmm, having a cola or something. You are very relaxed. No stress at all, no energy, no anger, stable. That is the stability. And hence I say the hybrid of benzene is having less energy and is more stable as compared to the canonical structures. And that's why I say energy difference is huge between these two. And that energy difference is known as resonance energy. This energy difference is known as resonance energy. Okay. This is known as resonance energy. So let's move to, if you want to write it, please write it down. Then we'll move to some other concepts here.
Is it compulsory for aromatic structure to be cyclic?
Uh, Aromatic cyclic, I think it is compulsory. It is compulsory because I don't remember seeing a aromatic compound without a ring. I don't.
So, but the three criteria does not satisfy
Mm-hmm.
that four
Acha,
endless planar and
acha,
the
acha. Okay,
conjugation.
okay, okay. Uh, then there was one criteria we missed all, and I think that was cyclic. The compound has to be cyclic, but I'm not so sure on that because uh, l- I'll have to once check whether it is compulsory or not. But by my experience, I can tell you I have not seen a compound which is not a cyclic and still aromatic. Okay. So all aromatic compounds are cyclic, which I have seen. But let me refer to the rules once more, and let me see if there is somewhere written that rule as well. I think it will be written somewhere that the compound has to be cyclic. Okay. Otherwise, it will not be aromatic. But let me check, because these can be sometimes a sort of minor details. There might also be an exception as well, because generally I am telling you I have not seen, but I'll have to see once more. Okay, let's move ahead now. Now, after this, aromaticity and aromatic compounds, there is something called anti-aromatic compounds. Something called anti-aromatic compounds. Now, what are anti-aromatic compounds? Now, anti-aromatic compounds are very similar, to the aromatic compounds. Why am I saying that? I am saying that because, let me tell you, the characteristics of anti-aromatic compounds. First, they are also planar. Second, complete conjugation. Now the difference lies in the third thing, and that is 4n pi electrons and not 4n plus 2 pi electrons. Difference lies here. Difference lies here. So the number of electrons in anti-aromatic compounds is 4n pi, not 4n plus 2 pi. And let me tell you something very, very famous about anti-aromatic compounds. These are highly unstable, compounds. Highly unstable compounds. Anti-aromatic compounds are highly unstable compounds. Okay, just write it down. You can write the example as this molecule, cyclobutadiene. Cyclobutadiene is the example. Let me redraw this for you. A square and 2 pi electrons. So 2 pi electrons means 4 electrons, isn't it? 4 electrons. So if you are going to calculate 4 and pi, by keeping n is equal to either 0, 1, 2 or any other whole number, then for n is equal to 1, you are going to find 4 electrons. 4 electrons.
So anti-aromatic are also cyclic.
Yes. They are also cyclic. I have not seen an anti-aromatic compound which is not cyclic. They are also cyclic.